It's a chaotic world out there. We find comfort in determining what to expect. We do this consistently and unconsciously every minute of every day. Our expectations are based on our own personal experiences, but these experiences are biased to our view of the world. When we are unsure of what to believe or what to do, our typical response is to ask someone we trust to provide their experience. Then we weigh their opinion against our own to form a new expectation about the world. What if we could accumulate information from a massive number of diverse experiences? How would this shape our opinion? Would it remove some of our own bias? Would it improve the accuracy of our expectations and predictions? Would it help us learn and grow? These are the kinds of questions that we set out to answer as we explore the underpinnings of artificial intelligence and its use in our world. Some of the most impactful events we experience in our lives happen rarely, like extreme weather, the pandemic, serious illness or injury. Now, these extreme events, however rare, have a long-lasting effect on our well-being. So why is it that they often catch us by surprise if we are constantly making internal predictions? Simply because our experiences don't match reality. If we have, in our lifetime, never experienced an extreme event, then we don't expect that they will happen to us. Imagine if we could reach into the past and ask someone who has experienced such an event about what they learned, what they would have done differently, their ideas for prevention. What would someone who experienced the 1918 pandemic influenza tell us about illness progression? What seemed to work and what made things worse? What socioeconomic class had a better outcome? Here is a snapshot of result from our 1918 pandemic influenza database. A simple analysis shows that an individual was significantly more likely to die by gunshot wound if they came from a blue-collar background versus a white-collar background. On the other hand, an individual was equally likely to die by pandemic influenza, no matter what background they came from. One lesson we can take away from this is that although war may not be an effective equalizer, the pandemic certainly was. You see, I see data like a message in a bottle, with hidden information that, given the proper tools, can help us make more informed decisions about extreme events. And machine learning is exactly the tool we need to accomplish this task. Now, before I continue, I must include the caveat that the words artificial intelligence and machine learning are often used synonymously. However, there is a key distinction. Machine learning is the act of teaching an algorithm to learn patterns in data, while artificial intelligence is the umbrella under which machine learning sits. Now, when I say the words artificial intelligence, many people think of something that looks like this, or something that looks like this. But I'm going to talk about something that looks more like this, and how mathematics this simplistic can make a large impact in our world. The pandemic hit Europe in January 2020. My family and I were living in East Germany at the time, watching closely to this new development that was unfolding. I remember watching the World Health Organization and being quite amazed at the full transparency of science surrounding COVID-19. And like many people, I was inspired to ask what I could do to contribute to a solution. And I was lucky enough to be included on a team of really amazing international scientists working out of an online hub in Australia. We wanted to address a difficult problem. How could we determine, as early as possible after infection, the COVID-19 patients who would go on to develop severe disease and hence need greater clinical care, and those who would go on to develop mild disease and could potentially recover at home? Now, one aspect of having severe COVID-19 is the development of a secondary bacterial infection after the initial viral infection. This is a rare event. It happens to about 10% of the population, but it's associated with significantly higher mortality. So our team wanted to see if we could build a model using machine learning, which could forward predict the likelihood of someone developing a secondary bacterial infection. And to do this, we turned to data, which could be easily obtained from a blood sample. These data are called gene expression, and taken together, the information they provide is like a snapshot of your body's functions at its current time. Our model identified 7 genes, which could accurately forward predict the likelihood of someone developing a secondary bacterial infection. In a test environment, it identified 100% of the patients who went on to develop secondary bacterial pneumonia 5 to 7 days before we could detect this bacteria in patient samples. With this kind of information, clinicians can provide early, vital medical interventions. So we were faced with a question, as scientists do. Why was something so simple, so accurate? The answer lies in our integration of expert insights and understanding. Virologists told us about the virus structure and its primary methods of entry and attack. Immunologists told us about the body's response to a viral and bacterial infection. Biostatisticians gave us the means to convert blood into numbers, and clinicians told us about the typical severity progression of a patient. And from the people who saw the value in donating their data, we were able to teach our mathematical model. In essence, the most vital components of our algorithm were the contributions made by humans. You see, machine learning for medical diagnostics is not meant as a replacement for medical experts, rather as a tool to help improve their perspective and hence diagnosis of a patient. When discussing the capabilities of machine learning in medicine, we ask about an algorithm's potential to improve society. And my arguments for its use revolve around the phrase medical equity, which is a phrase used to describe a setting in which all of us have a fair and just opportunity to obtain the highest medical care possible. Fair and just across age, gender, culture, income, ethnicity. If a medical system does not have equal representation of a population, then it is much more likely to fail someone. An experienced clinician has seen about 156,000 patients in the lifetime of a 30-year career. And that is a lot of people. But given how unique we are, the likelihood of that clinician having met someone similar to you is quite low. So their diagnosis of your condition will always be a little biased to their experience. Imagine a tool which could incorporate the experiences of 1 million or more people across a huge range of backgrounds. The likelihood of someone in that pool being similar to you is much higher. With this kind of reduced bias, the ability for machine learning to address medical equity is incredible. So this leaves us with a very serious question. Can we actually trust the outcome of an algorithm? You see, bias in an algorithm occurs in the same way our own bias develops. We form opinions and make predictions based on our personal experiences. In a similar way, an algorithm forms an opinion based on the data that it's given to learn from. To even begin a discussion about trusting the outcome of an algorithm, we first need to trust the data or a set of experiences that it's provided. This is why our initial goal is always to gather as much data across as many backgrounds as possible. Once our model learns on these data, we test it on a separate group of data that it's never seen before. And from this test, we determine its accuracy by calculating how many correct and incorrect predictions it's made. If our model performs very poorly, we update it with insights from experts in the field of interest, retrain it, and retest it until it is as accurate as possible. This accuracy is a measure of how confident we are in our model's ability to perform a task. And we want this confidence to be very high for high-risk tasks, like 95 or 99%. Machine learning, to help us make more informed decisions about extreme events in our lives, is an exciting new direction in science, and we are very reasonably optimistic about its capabilities. However, it is incredibly important to be aware that we should never trust the outcome of any AI blindly. For example, if I asked an AI, how many rocks should I eat today? It might tell me that I should have one small rock for the vitamins and minerals. It's a chaotic world out there. A product of this chaos is that we will never be able to say something will or will not happen with 100% certainty. There is always a risk of failure, however rare that might be. What we can do is mitigate, perhaps even lower the negative impacts of an extreme event, and improve our estimates of these risks. And we are getting much better at doing this. In both cases, our responses and decisions are situational and rely on the interpretations and interventions of decision makers, of humans. Finding out where we fit in a world of AI lies in our choice of contribution to the overarching direction of humanity, which can take many forms. And while a well-trained AI can help reduce some of our bias and help us make more informed decisions, there is no replacement for humanity's insight, creativity, and intuition. Thank you.